All right, welcome to week 6, Math 95, Intermediate Algebra students. Hopefully you noticed I added another surprise quiz. It is due this week tomorrow. Quadratic equations, the stuff you've been working on for the last couple of sections. So I'll review some problems that are like those quiz questions. If you haven't gotten the point of these quizzes yet, they are questions that you will see on your final exam. Similar questions, different numbers. There's 3 more to come before the end of the term. Daily work schedule. So hopefully you still have that somewhere you can look at regularly. You should be finishing up section 4.5 today, so you can work on section 4.6. Moving on, 4.7 and 4.8 are pretty short. You'll fly through those. I'd say the most important sections in this chapter are 4.4 and 4.5, so get good at those. And then a couple people have already taken exam 2, I see. That's due by next Monday, a week from today. So make arrangements for that now. So again, this week we're playing around with quadratic equations. We've played around with square roots, completing the square, and now the quadratic formula. So I'm going to review completing the square and the quadratic formula and a couple of other ideas. So as far as quadratic equations go, at the moment we have 3 different versions of them. There's standard form, some number times x squared plus some number times x plus another number. There's vertex form, and then there's factored form. So we've been playing with factored form since our first chapter this term. Vertex form is relatively new. We just started playing with that at the beginning of this chapter. In terms of shifting left and right is what the h does. The k shifts the parabola up and down, and the a flips it vertically, stretches or compresses the parabola. So I have an example over here. These are all the same quadratic equation in different forms. So here I have it written in factored form. Factored form is nice because it allows me to find the x-intercepts, which by setting this equal to 0, I can see that x equals 1 makes this 0, or x equals -3 makes this 0. So I have the point 1, 0 or -3, 0 on the graph. X-intercepts are also called roots of the graph or zeros of the function. Standard form here, notice they all have the same leading coefficient, the 2. That 2 tells me this is facing upward, opening upward, so it could catch water. And the 2 is a vertical stretch, so it's going to be narrower than your standard parabola. And I'll show that in a minute on the graph. This also tells me the y-intercept. If I plug in 0 for x, that means I'm not moving left or right. I'm stuck on the y-axis, and y is -6 there. So I have the point 0, -6. And this one here is what's called vertex form. And it tells me the x value I can plug in here, -1, makes this first part disappear, leading to y equals -8. So the vertex, that's either the minimum point on the graph or the maximum point on the graph. In this case, it's opening up, so that would be the minimum point on the graph is -1,8. So let's check out these features in a graphing program. So I have Desmos up and running here. And I typed in the standard form. Y equals 2x squared plus 4x minus 6. And here you can see that I have the point 1, 0 and -3, 0. Those are the x-intercepts that factored form helps me find. I have the y-intercept that the standard form helps me identify. And then down here, I have the vertex of -1, -8 that the vertex form helped me identify. Now, I mentioned this is narrower than the standard parabola. So if I were to just graph y equals x squared, here I can just grab that and move it. No? Oh well. It's a little bit wider. I know what I can do. I can shift it over. So let's do parentheses, parentheses. So x plus 1, I'll shift it over to the left. And then I want to drop it down by 8 to get the same vertex. Okay, so I just took the standard parabola, shifted it left 1 and down 8. So you can see that my new one, because of that 2 out front, is narrower. It's a vertical stretch there. Now, I can just tweak this a little bit by multiplying a 2 out front, and that'll give me my stretch. So notice this new blue function sits exactly on top of the red standard form, meaning these two versions are the same function. Now there was another version, that factored form. Factored form would be y equals 2, and factoring the one above, I get x, let's see, what is it, plus, let's see, minus 1, and then times x plus 3. And so now I have this green one that sits on top of the other two. So we have the red version, the green version, and the blue version. So they're all the same exact graph, just three different ways of looking at it, and each has their benefits. Does every quadratic equation factor? Some not so nice. So I'm going to look at a different version of that next. So let's consider a relatively simple one. How about y equals x squared minus 2x minus 2. So you could try and factor this. The AC method says take that 1 in front. 1 times negative 2 is negative 2. Factor negative 2 in as many ways as you can. So I'm going to ignore the negative for a minute. That factors as 1 times 2. Since that's a negative, I should subtract these to try and get the middle. Well, 1 minus 2 is negative 1. That doesn't work. Or 2 minus 1 is 1. So this does not factor. With our AC method. So I could complete the square, and which is my preference for solving this kind of thing. So suppose I'm trying to solve x squared minus 2x minus 2 equals 0. Completing the square, we would take this minus 2 over to the other side by adding it to each side. So that gives me x squared minus 2x equals 2. And then the trick from there, switch to blue, is to take half of that middle coefficient. So negative 2 divided by 2, that gives me negative 1. And then I want to square that number, which gives me a 1. So the 1 is the number I want to add to each side here. And the point of adding the 1 on this side is I've created the perfect square. And this number, the first, when I divide it by 2, tells me what I have the square of. I have the square of x minus 1 because of that minus 1 there. I had to add 1 to keep the equation balanced, equal, and so I have a 3 on the other side. Once we complete the square, we can take the square root of both sides. Now the square and the root cancel if I adjust the other side with a plus or minus. And then I can add 1 to the other side, so I get x equals 1 plus or minus the square root of 3. So that means for the x-intercepts here, I get the point 1 plus the square root of 3, comma 0. And I get the point 1 minus the square root of 3, comma 0. And we can double check what that is about. So let's go to our calculator and get approximations here. So 1 plus the square root of 3 is about 2.7-ish. So this one here is approximately 2.7, comma 0. And the other, 1 minus the square root of 3, oops, is negative 0.7 roughly. So let's take a look at the graph and see what we get. So we should see these 2 points on the graph. And sometimes, again, you need exact answers, and sometimes approximate. That's what the wavy equal sign means. So Desmos, help us out here. Let's get rid of these functions and add a new one. Y equals x squared minus 2x minus 2. And I can see I have about negative 0.7 is one x-intercept. About 2.7 is the other intercept. I should find that the y-intercept is 0, negative 2, right here. And it looks like the vertex is 1, negative 3, so let's see if we can figure that out. So completing the square can help with that too. So this is just a little review of before. So y equals x squared minus 2x minus 2. So there's a couple different ways to go about this. One way is to just separate that negative 2 off to the side and just think of it as x squared minus 2x, and then put the minus 2 over here. And then like before, we took half of that middle term, this one right here, cut it in half, right? That's negative 1. And if I square that negative 1, I get 1. So I would like a plus 1 to be right here, because the point is that that's now the square of x minus 1. Now, I can't just add 1 here. Before, what we did is we added 1 on one side and added 1 on the other side. Instead, what I'm going to do is on this right side, I'm going to add 1 and I'm going to subtract 1. So plus 1 and minus 1 on the same side balance each other out. So then I can say this part right here is going to give me a minus 3. So what I've discovered is that my original equation can also be written as x minus 1 squared minus 3. And this tells me the vertex. Vertex is always the opposite of the number you see there, 1, and exactly the number you see there for y. And that's exactly what Desmos told us, 1, negative 3. Now that's fine that Desmos tells us that, but you're going to have to show me some work on your next test to demonstrate how you come up with that besides Desmos. And one way is completing the square. So another way we can look at this is with the quadratic formula. So let's take a quick look at that. And some of you have probably seen the quadratic formula in your past life. That is, life before this class. And what it says is if you have something that looks like a number times x squared plus some number times x plus another number, and that's equal to 0, very important that you have that 0 there, then you can always solve this, and the answers will always look like this. The opposite of the middle term, plus or minus this big old square root, and in the square root is the middle term squared minus 4 times the first term times the last term, all divided by twice the first term. That's the quadratic formula. Interesting thing about the quadratic formula, it's kind of a side note. The 2a is dividing everything up here. So both the negative b is being divided by the 2a, plus or minus, and the square root is divided by the 2a. So b squared minus 4ac. And a cool way to think about this right here is this negative b over 2a here. That's kind of a fixed point, we could say. Let's see, switch colors, there we go. And the plus or minus, oh, I'm supposed to say point, the plus or minus there, and this number on the other side is a distance to travel. So number-wise, what we have is we have this negative b over 2a in the middle. And then first, we're supposed to go plus the distance over to the other side to get 1 intercept on the right. And then minus means take that distance and go to the left, that same amount. So we got plus the distance on one side and minus the distance on the other side, and that gives us our other intercept. And remember, first section of this course In the second section, we kind of looked at that idea. If I know the x-intercepts and I find the number in the middle, that's always where the vertex lives. Okay? So the negative b over 2a always helps me find the x value of the vertex. To find the y value, we have to plug that back in, which is a bit of work. This number is not the y value, it's just the distance on either side to travel to get x-intercepts from that middle x value. So the quadratic formula tells us two things. The negative b over 2a tells us how to start finding the vertex, and then the whole thing finds our x-intercepts. So we're going to apply that to that last equation. Y equals x squared minus 2x minus 2. And if you're new to the quadratic formula or you struggled with it before, I recommend you do two things. First, write down a equals 1, b equals negative 2, and c equals negative 2. And then verify that you copied them correctly with the right signs. Then write down the quadratic formula. Opposite of b, plus or minus the square root of that b squared minus 4 times a times c all over 2a. After you've identified a, b, and c and rewritten the formula, that'll also help you memorize it, plug in your a, b, and your c. So I get then x equals the opposite of negative 2, common place to make a mistake, of sign change, and then plug in, sometimes using parentheses to be careful, all over 2 times 1. So then I kind of clean up this. This is called the radicand here, or the discriminant. So let's see, negative 2 times negative 2, that's a 4. And then I have minus a negative, so that's a plus. 4 times 1 times 2 is 8. So the radicand here, the discriminant, is 12. All right. So I've got 2 plus or minus the square root of 12 all over 2. Now the square root of 12, you might note from the previous chapter, can be cleaned up, because we know that 12 factors as 4 times 3, and 4 is a perfect square. So this becomes 2 plus or minus, the square root of 4 is 2, but the 3 is stuck inside the root. And you can't cancel unless you can factor something out. So those of you who are thinking, man, I'm going to nail those 2's, don't do it. First, note that you can factor a common 2 from the top and bottom. The two sides of the plus or minus. So I'm going to pull out that 2. Factoring is like dividing. So if I divide this 2 by 2, I get a 1. Plus or minus, I'm factoring the 2 from 2 square root of 3, which leaves just the square root of 3. Now that that 2 can be factored completely out, I can cancel it. But I can't cancel until I do that factoring. Canceling is basically dividing and saying a number divided by itself is 1. So it looks like the final simplified answer here, switch color, is 1 plus or minus the square root of 3. Sometimes completing the square is easier. So that's what I did back here. So completing the square was getting from this step here down to that step there. I found that to be a little easier than cleaning up the quadratic formula here. So my usual strategy is if there's a 1x squared out front and the middle term is even, completing the square is easier. Otherwise, I use the quadratic formula. You decide on your strategy. So let's take a look at a couple other problems. Your homework, let's grab one from 4.5. So here, quadratic formula section, I've got x squared plus 8x plus 24 equals 0. It says use the quadratic formula. So let's write that down. Now this is one where I would prefer to use the completing the square. So I'm going to do that first, and I'll use the quadratic formula second. So again, I think I like to use the quadratic formula here because there's a 1 here, and that's even. So bringing the 24 over to the other side by subtracting it, I next need to take half of my middle term. So let's put it down here. 8 over 2 is 4. And then I have to square that 4. That gives me 16. So that 16 is the magic number that goes here. I also have to put it over there because I need to keep things equal. The point of that 16 is to make a perfect square. I now have the square of x plus 4. On the other side, negative 24 plus 16, that looks like a negative 8. Yep. So now that I've completed the square, I can take the square root of each side. So I get x plus 4, provided I adjust the other side with a plus or minus. Anytime we have a negative inside of our root, an I comes out. So I have some cleaning up on this side to do. So I'm going to write that as plus or minus I times the square root of 8. And then note that 8 is 4 times 2. So I can clean that up. So I got plus or minus I. Square root of 4 is 2. I'll put that there. And this 2 is trapped inside still. On the other side is still x plus 4. So now I can subtract this 4 to the other side. X equals negative 4 plus or minus 2I square root of 2. Now, note, because this has an imaginary number that it's complex, it means there should be no x-intercept. So there's 2 ways to check this. The one way that's not the best way in the world is to look at it graphically. So if I look at the graph of this, let's clear these guys out. Y equals x squared plus 8x plus 24. Even on my screen, and zoom out, I can see it's completely above the axis, so it has no x-intercepts. So that fits me finding an imaginary number or a complex number. The question is, did I find the right complex number? And really, the only way to check that is to plug back in. So if you really, really, really wanted to check, then you would take one of those zeros here, for example, negative 4 plus 2I square root of 2, and you would have to take that and plug it in for x here and here, and hope you could simplify it to 0. And most calculators don't do well with complex numbers, so you'll have to do that by hand and see if all the i's cancel, leading to a 0 in the end. And that should happen. You should find that. Next, quadratic formula. So I'm starting off with, so this will be a nice check because we better get the same answers. 8x plus 24 equals 0. So my recommendation is write down what A is, what B is, and what C is, and double check that you get the signs correct. And write down the quadratic formula, the opposite of B, plus or minus the square root, B squared minus 4AC all over 2A. Then plug in. So opposite of negative 8, plus or minus square root 8 squared minus 4 times 1 times 24 all over 2 times 1. Then clean it up a bit. So that gives me negative 8 plus or minus, what are we going to get here? 8 squared is 64. And then that stays negative. 4 times 24, let's see, 4, it's 48 times 2 again is 96, I believe. And then subtracting here, 96 minus 64 is going to give us what? Negative 32. Yep. So that gives me square root of negative 32 over 2, and then start cleaning that up. So let's see, 32 needs to be factored. 2 goes into 32 16 times. 2 goes into 16 8. 2 goes into 8 4 times. Oops. 2 goes into 4 twice. And every pair of these comes out as a 2. So there's a 2 that pops out, another 2 that pops out. And then the negative pops out as an I. So where are we at? We've got x equals negative 8 plus or minus 2 times another 2 times an I, and then this 2 right here is still trapped inside. So be careful there. I can factor a 4 out of the numerator. So 2 times 2 is 4. And well, we could take a negative. Suppose I take negative 4 out. Negative 4 goes into negative 8 2 times. Plus or minus, minus or plus, that doesn't change much. 4 is gone, so I get I times the square root of 2 all over 2. And then 2 goes into 2 once and 4 twice. And I'm running out of room, so I've got negative 2 times 2 plus or minus I square root of 2. If you want, you can bring that 2 back in. So 2 times 2 is 4 plus or minus 2I square root of 2, which I'm pretty sure is what we found right there. Yep, same answer. Cool. So complete the square and quadratic formula, justify the same answer. These are the only x values, and there's 2 of them. Right? Negative 4 plus 2I square root of 2, and negative 4 minus 2I square root of 2 are the answers. All right, that's it for now. It's kind of an overview of where we've been last week and what you're doing this week. Don't forget, you need to take the end, let's see, the practice. So if it says optional, it's optional. This is not optional. You got to do this practice exam before you do the real exam. Here, real exam has to be proctored, so you either need to get to a testing center or sign up with ProctorU. You need to take that by Monday, a week from today. So get busy, stay in touch, and do good math. Bye-bye. Can exit. Interesting. Hello. There we go. Have a good day.